Hi everybody, welcome back. In this lesson we're going to be learning about customary measurement and how to do conversions with these measurements. So for the memory piece you have these 5 pieces and the pocket that these will go in. And in the assembly video I showed you how to do the assembly for this and also to put that pocket down in your notebook. I want you to have this available so that you can pull this out and refer to it as you need to, and then you can put it back in the pocket for safekeeping. But I wanted to make this one a little bit more portable than some of the others. So I'm not going to read all of these. I just want to briefly look at each of them. And hopefully you have already assembled yours. Mine is not assembled on the screen, and I'm going to leave it like it is here. But I do want to at least go through them with you and point out just a few things on each one. So the first one is the distance. Actually, the first one is the cover. And we're looking at customary measurement as opposed to metric measurement. These are two separate systems of measurement. The United States is one of the few countries in the world that uses customary measurement. Most of our neighbors and the larger country, in fact, all countries around the world, most of them use the metric system. And we are going to talk about that too, because you, as an educated person, need to know about both of them. But the United States still uses customary measure. And I've divided these into 4 different categories. The first is the category of distance. Distance can be used to measure the space between 2 points. It can be used for area and volume and all kinds of things. It's not just point to point. It can be used to measure square footage, square miles, cubic yards, cubic inches. Lots of different types of things can be done with these. But the units are mile, yard, feet, inches, and then I have included one here for square feet because I wanted you to know what an acre was. This is an area measurement because we're looking at square feet, the amount of ground covered. But an acre sometimes pops up in math questions, and I just wanted you to have that one. And I'm not going to read all of these. I'm just pointing out things here. The next one is capacity, which is used to measure volume, how much something will hold. Want to call your attention to this word fluid. There is a difference between an ounce and a fluid ounce. For capacity, we're looking at fluid ounces. 8 fluid ounces equal 1 cup. There are some smaller than a cup. You've got teaspoon, tablespoon, but I didn't break them down quite that far. If you are going into the medical field, you probably will have to learn them down that far, especially in the metric units. We deal with smaller ones. But the capacity units are ounce, cup, pint, quart, gallon, and then sometimes we talk about half gallon, which is 2 quarts. But I didn't put that one in here. We can work with these and figure out what we need to know. Weight, this is the other ounce that you need to be concerned with. This is not a fluid ounce. This is a measure of mass, or actually weight. 16 ounces equals 1 pound, and 2,000 pounds equals 1 ton. And then the units of time, there are lots of these, but these are probably the most familiar because we use them every day. If you follow any kind of a schedule, you are used to hours and minutes and days and weeks and so on. One thing I want to point out here is this one, that 1 year is 365 and 1/4 days. This is why every 4 years we have a leap year. That is to make up that 1/4. The Earth takes just a little bit more than 365 days to make one revolution around the sun. So that 1/4 of a day is 6 hours. So we add those fourth days up, and every 4 years we have a leap year. Leap years occur when we are electing a president. So if there's a presidential election, you will have that February 29th as your leap day. The units here are seconds, minutes, hours, days, weeks, months, and year. So there are quite a few of these. You notice that I did not give you 1 month equals so many weeks or so many days. And that is because the months vary in terms of days and weeks. Days, really. There aren't full weeks, but the days make a difference. This is the way I learned to remember the numbers of days in each month. There are lots of other ways that you can do it, but this is the one I learned, and I thought I would share it with you. I memorized this sentence. 30 days hath November, April, June, and September. February has 28. All the rest have 31. So whenever I have to think about the months of the year, I can remember that these 4 have 30 days. February has 28, and then all the rest have 31. Okay, let's use this memory piece that you have assembled. And I want you to go ahead and glue down the pocket first. So find the page that you want to use and glue down this pocket. And this pocket will hold your memory piece. You can just put it in there and out of there whenever you want it to be there. And so let's call this page, you know how I feel about titles. This is Customary Measurement Conversion. And we're going to use the rest of this page to do some problems, or to do a problem. I'm going to walk you through an example, and then we'll do some practice. So to do a conversion, there are some steps that I want you to write down. And I tell you what, here above your pocket, let's just put the example because I'm a little bit tight on space. So write this example in there with me. And we can stop the video. You can stop the video as you need to. I'm going to use one with a capacity because I find that those seem to be the hardest for students, or at least when I was teaching, that's what we saw to be the hardest set. So we'll do a capacity example, and then we'll do some others. So let's say, how many pints are in 15 gallons? And I'm just making this up off the top of my head. There are many of these problems you could come up with, but this is the example that I want to do. So under the pocket, let's put the steps. So step 1 is to set up the conversion proportion. Conversion means changing one thing into another. And here's how you set up a conversion proportion. I want you to draw 3 lines, just like so. And between them, we're going to put the equal sign. So to do a conversion, you need to set up this frame. And I'm going to copy that. You can redraw yours, but I want to just copy mine. Step 2 is to write the word ratio. And right now this may seem very foreign and very bizarre, but I promise you, if you practice these, you'll get so good at them. You won't even have to think about what you're doing. So the word ratio, a ratio is a comparison. The word ratio is going to be this first one, always. So let me move this up so I can save some space here. I'm running out of room. I think 4 steps will do it. Okay, so here's how you do the word ratio. You look at your problem and you find the 2 units that you're comparing. We are comparing pints and gallons. It may be miles and yards or feet and inches or cups and gallons or days and weeks. It can be anything, but there will always be 2 of them. And you write those as your word ratio. Pint and gallon. So this will come from your problem. And it always goes first. Okay, so I'm going to copy this one. And I'll give you step 3. Step 3, you are going to write the reference ratio. Okay, so here it comes. This comes from your memory piece. So you need to find the conversion for pint and gallon. And let me go back to mine and I'll show you where it is. Pints and gallons, that's capacity. So you go to this tab and you find the one of these that talks about pints and gallons. And right there it is. 1 gallon equals 8 pints. That's the memory part that you have to know. Okay, so you come back over here. We're going to write the second one. 1 gallon. So you see how I'm putting the 1 with the gallon is equal to 8 of these. So 8 pints, 1 gallon. That's called the reference ratio. That's the memory one. The one that you come from, one that comes from memory, your memory piece. Okay, so we've got the reference ratio. We've got the word and we've got the reference. So we've got 1 more to do. And then that is going to be step 4. Set up and solve the proportion. That's the last step. So here we go. I'm going to put it, this time I'm going to put it right over here because I need some space. So we go back to our problem. Look back at the problem that we're solving. And you see that number right there. That's what I'm after. The 15. In this case, it's a 15. And that goes with pints or gallons. That's 15 of these. 15 gallons. So I'm going to bring that 15 down here, and I'm going to put it in the gallons row. It's very important. It's not 15 pints. It's 15 of these. Okay, 15 gallons. And what you have here is a math problem that is solvable. And I'm going to show you how to solve it. This is called solving a proportion. The first thing I want you to do is draw what I call a peanut. And that is not an official term. This is an Amanda term. But we're going to draw a peanut around the 8 and the 15. Because look at if I tried to draw the peanut this way. There's nothing there for me to put in the peanut. So we can't draw it that way. It has to go this way. So you are going to multiply the peanut. And again, your college professors will not call that a peanut. It just looks like a peanut to me. So we're going to say 8 times 15. And you can use a calculator here if you need to. Is 125. And then you will always divide by the number that's not in the peanut. That's why I want you to draw the peanut. If you don't, you'll end up dividing by the wrong thing. So we will say 125 divided by 1 is 125. And that is your answer. That's this missing number right there. So in 15 gallons, there are 125 pints. The answer here to my question, there are 125 pints in 15 gallons. And that is called a conversion. And we're going to do more of these, following these 4 steps exactly the same way. Do it exactly the same way every time, and you won't miss these. If you practice them enough, you will get very good at them. Okay, let's try a few more here. So I'm just going to go to a new page, and we're going to practice. Let's do how many weeks are in 14 years. Now, you may not need a proportion to do this. If you know how to do this without one, don't draw the proportion. This is just one way to do it, but it will work every time. So you set up 3 ratios, and we're going to say that they're all equal. The first step is to set up the word ratio, and we have weeks and years. So you just write that. You can put years on top. It doesn't matter. Week and year. The second step is to write the memory ratio, the reference ratio. So I'm going to look back over here to find what I'm looking for. It's not this one this time. I'm looking in the time section. And weeks and years are my 2 words. So here's the conversion. 1 year, 52 weeks. So I come back over here, and this is where it's tricky. 1 goes with year. 1 year is worth 52 of these. So this is called the reference ratio. This is the word ratio. And then to get this other piece, we're going to look for this number, which is a 14, and that is with years. So I'm going to put that on the years row, not weeks, because it specifically says years. And then we're going to draw the peanut. So the peanut goes around the 52 and the 14, and you always multiply a peanut. And I am not even going to attempt this in my head because we know how that would end up. 52 times 14. Let me get my calculator handy here. 52 times 14 equals 728. But remember, you have to divide that by what's not in the peanut. And in this case, it's a 1. It won't always be a 1. So the answer to this one is 728. There are 728 weeks in 14 years. Okay, let's do another one. How many ounces are in 11 pounds? How many ounces are in 11 pounds? So I'm going to draw my framework, always 3, and then I look at my problem to get the words, and I have ounces and pounds. So my words are ounce and pound. Then I need the memory ratio, the reference ratio. So I go back over here, and this time I'm not dealing with time. I'm dealing with weight. So you flip to the weight section, and there it is. 1 pound is 16 ounces. So I come back here, and I say that 1 pound is 16 ounces. So there's the reference. That one is a rule. It's a math rule. It's set in stone. Then the 11 goes with pounds according to the problem. So we put it down here. And let's draw the peanut. You always multiply the peanut. 16 times 11. And this is actually called solving a proportion, guys. So 16 times 11 is 176. And 176 divided by 1 is 176. So there are 176 ounces in 11 pounds. So you see that process doesn't change. The reference ratio changes, whether you're dealing with weight or time or distance, but this process will never change. Okay, let's do this one. How many fluid ounces are in 106 cups? How many fluid ounces are in 106 cups? So the first thing I'm going to do is draw my framework, put my equal signs in there, and then let's get the word ratio. We have fluid ounces and cups. So I'm going to put fluid ounces and cups. And then I'm going to go to my conversions. I'm going to bring these right over here so I don't have to flip across so many. And those are capacity units. There it is. 1 cup is 8 fluid ounces. So 1 cup is 8 fluid ounces. And then you and I in our problem are dealing with 106 of these. Whoa. 106 cups. So we've got 106, and here is the peanut. 106 times 8. Use the calculator. This is where I make the mistakes because I don't do math in my head. Is 848. And then you divide that by what's not in the peanut. Don't be lazy and skip that, or that'll come back to haunt you at some point. So there are 848 fluid ounces in 106 cups. Okay, Let's do another one. Let's take it up a step here. How many days are in a half a year? Don't worry, the process never changes. That's the great thing about math. People are often so terrified of math, but what they don't realize is if they learn the steps, they never change. The rules don't change in math like they do in English. This is a very step-by-step, predictable pattern. Days, year. Get your words first. And I really want to just say day. Then get your conversion. Get the memory, the reference piece that you need to know. So we're looking at time that matches up days and years. And right here it is. Now, if we want to be really precise, we're going to use the 106. I'm sorry, the 1/4. I'm not. I'm just going to use the 365. We're going to say that this is not a leap year. Let's just make that clear so we know what we're talking about. So in a year that's not a leap year, there are 365 days in 1 year. And then our number that we need to look for is 1/2. Don't panic about that. It's just a number. And it's a year, so we're going to put 1/2 down here. Now with your Casio calculator, you can multiply 1/2 times 365. But with any calculator, you can multiply 0.5 times 365. And that's the same as a half. So I'm going to use that one. So here comes the peanut. 365 times a half. On the calculator. Is 182.5. Don't panic. It's okay. That's just a number, like any other number. Divide it by 1, and it's not going to change. So there are 182.5 days in 1 year. And you can write that as a decimal or as a fraction. It doesn't matter. So 182.5. You absolutely can get fractions in these or decimals. It doesn't matter. But the process has not changed. You see how it's step by step, the same thing over and over. Okay, let's do a couple more. One more, I guess, is all I have room for. And let me give you a word problem this time, an application problem. One elephant weighs 2,000 pounds. How many tons do 6 elephants weigh? Now, a lot of people just go all to pieces when they get a word problem. But I want to show you that it's the same thing, guys. There's no reason to let those word problems scare you. If you know the steps, you've got this. The two units that we're looking at are pounds and tons. That's my word ratio. And this time I'm going to put tons on top just to show you that it works. Okay, so we got the word ratio. The next one is the reference ratio. How are those two things related? So I go over here to my weight card, and I see that 1 ton is 2,000 pounds. So I come back over here, and I'm going to put that down. 1 ton is 2,000 pounds. Okay. Now, be very, very careful here. And I want to show you this. You go to mark that other number. No problem. But then you look at the next word to see what that number goes with. And it's elephants. Now, elephants is not here. We've got tons and we've got pounds. So we're going to have to do a little bit of thinking here. If one elephant is 2,000 pounds, I have to abbreviate. 2 elephants would be 4,000. 3 elephants, 4 elephants, 5 elephants, 6 elephants. So I'm going to say 6 times 2,000. So I'm going to go all the way down here to 6 elephants. That's 12,000 pounds in those 6 elephants. So this time, be so careful. This is why it's so important to read and pay attention. Where does that 12,000 go? 12,000 tons? 12,000 pounds? It's 12,000 pounds. So the 12,000 that we just calculated goes right there. It's on the pounds row. Okay, so then I'm going to draw the peanut. The process doesn't change. You still draw a peanut, and you still multiply it. So 12,000 times 1 is 12,000. And you still divide by the number that's not in the peanut. And that is 6. So 12,000 pounds is the same as 6 tons. 6 elephants weigh 6 tons. So wanted to show you that because with word problems, always the application problems are a little more difficult because you have to really read and pay attention. But the process does not change. We've done 6 of these now total, counting the example on the other page. And that process is exactly the same every time. So this is how we do conversions. This same process is going to help us with the metric conversions. So we'll get to those in another instructional video, but let's do some more practice with this one before we do that. So keep that memory piece handy. Keep it in this pocket so you can pull that out and refer to those. And then I'll show you how to do this with the metric system as well. I'll see you soon. Bye-bye.